Welcome to Statistics Fundamentals. The Section 1 is an introductory course. As a first step to learn statistics, in this section, you will learn what statistics is and what data is. You will also learn essential terms such as independent variables and dependent variables. First, let's understand what statistics is. Before diving into the world of statistics, let's see what statistics is. When we use the term statistics, it can have two meanings. In some cases, it means some findings obtained from research data. These findings are usually represented as numerical values. It is often a numerical summarization of some real phenomenon. In other cases, we use the term statistics as a scientific field. Since this course is about theory and practical methods of statistical analysis, here, unless otherwise noted, the term statistics means statistics as a scientific field. As a field of science, statistics is a discipline that concerns collecting data and mathematical analysis of the collected data for describing data and making inference from the data. Here, data is usually supposed to numerical data but is not limited to it. By using various data transformation methods, we can use non-numeric data in statistical analysis. By using statistical methods, we can obtain insights from data and use the insights for answering various questions and decision-making. For example, by using customer data, we can predict who will purchase a product and who will not. By using employee data, we can see the average level of employees' work motivation. By using citizens' income data, we can see the income inequality. And by using an experimental data, we can examine whether a psychological intervention will lead to improve the social skill of the subject employees. These are just a few examples. We can use statistical method for various purposes other than the above. However, if we do not use appropriate methods, statistical analysis will result in meaningless or misleading findings. Suppose we want to know the factors that can improve employees' work motivation. Say we ask employees, please tell me the reason why your motivation is high or your motivation is low. Will this question provide us with meaningful insights? Sometimes will do, but sometimes will not. Suppose we are asked such kind of questions. We sometimes do not answer such questions honestly because we want to appear to be a nice person, or want to hide our guilty consciences. For example, for some of us, work motivation depends on financial reward. But many of us are not likely to say so honestly because in many societies there is a social norm that we should not stick to money. And in another case, our work motivation can decrease because we want to be promoted to a managerial job, but one of our colleagues beat us to it. In such a case, it is not comfortable for us to say, I was demotivated because my close associate was promoted to a manager. One alternative way to do an appropriate analysis in such a problem, we can collect data of employees' work motivation and potential predictors of work motivation. And using this data, we can do hypothesis testing, which will be covered in later courses. An important point to note here is that to obtain meaningful insights from data, we need to learn statistics both in practical and theoretical viewpoints. To learn statistics, we need to know the meaning of two essential terms first. They are population and sample. In statistics, a population is an entire pool of an object of interest, and a sample is a subset of the object collected from the population. Suppose I want to know the average level of work motivation of my subordinates. In this case, by using some survey, it's not difficult for me to obtain data on the motivation level of all of my subordinates. So, the dataset contains data of an entire pool of the object of my interest. That is, a population. And suppose I want to know the average level of work motivation of company employees. In this case, I can't obtain data on the motivation level of employees all over the world. So, I will do the next best, that is, collect data from a certain number of employees, for example, hundreds of or thousands of employees from some companies. We use the term measurement to represent some numerical or non-numerical attributes of each observation of a population or a sample. For example, here, we have a sample dataset that consists of 5 employees. Tom is one of them, an observation of our sample dataset. His age is 25, and his motivation level is scored 6 out of 10. In this case, the age of 25 and the score of 6 are measurements of this observation. And she, Mary, is another observation, and her age is 26 and motivation level is scored 7 out of 10. These are also measurements of this observation. And putting together the measurements of all of the 5 employees, we can get the sample data. In other words, a sample data consists of measurements of each sampled observation. We can obtain some summary data from a sample. It is called a statistic. For example, if we get the data of work motivation, we can calculate the average motivation level. The sample's average motivation level is a kind of statistic, while a statistic is a summary data of a sample data. A parameter is a summary data of the whole population. So if we can obtain the data of average motivation level of employees all over the world, the entire pool of employees, the average data is a kind of a parameter. Since statistic is about just a subset of the population, a statistic value usually does not exactly equal to the parameter value. We can easily imagine that usually these 5 employees' averaged motivation does not equal to the average the motivation of employees all over the world. However, by using statistical methods, we can infer a parameter from a statistic with a certain level of certainty. Thanks for watching. If you like this video, please don't forget to like, subscribe, and also press the bell icon for future updates. See you in a new video. Take care and Allah Hafiz.